All right, the topic of section 12.2 is the word series. A series is nothing more than the sum, most important word, of the terms in a sequence. So basically what you do is you take a sequence and you add all the numbers together. For example, let's say I had the sequence of even numbers. 2, 4, 6, 8. The series for that sequence would be 2 plus 4 plus 6 plus 8. That's the series. You take the numbers in the sequence and you add them together. And usually we're going to evaluate a series. And in this case, if I evaluate that, I would have an answer of 20 if I add all these numbers right here together. So that's what we're going to be doing here in section 12.2. Now, a series in math is represented by summation notation. The symbol in math is a goofy letter Z that looks like this. And I believe you can find this on your graphing calculator. By pressing the math key. I think it is under there. Now, how does this symbol work? It has a value of n, whatever. It could start at 1 or it may start to something else. And it tells you the first value and the last value. The first value of n is right there on the bottom of the summation notation. And the last value of n is on the top. And in the middle, right here, that I wrote in black, will always be the explicit formula. The explicit formula goes there. For example, let's say I had the summation notation from n equals 1 to 4 of 3n. Well, how do you evaluate that? Well, the first value of n is 1. And I'm going to write over here, a sub n. Put a little line here, we'll call this a sub n. So, if I put 1 in for n, the first number in our sequence is 3. Now, it says I need to go from 1 up to 4. That means I got to include every number between 1 and 4. So that means I got to put 2 in for n, and 2 times 3 would be 6. And then I got to put 3 in for n, and 3 times 3 is 9. And then I got to put 4 in for n because 4 is my last number. I put 4 in there, and I get 12. So here is my sequence of numbers, but since this notation wants a series, that means my series for this problem would be 3 plus 6 plus 9 plus 12, which gives us an answer of 30. Let's do another one. Example 2. We're going to talk about the summation notation from n equals 2 up to 5 for the explicit formula 4n minus 1. Well, again, you can make a table if you want. If you prefer not to, that's fine. But it tells me my first value for n is 2, and my last value of n is 5. So I got to count from 2 to 5. 2, 3, 4, and 5. And now I got to figure out my terms. So if I take 2 and stick it in there, I get 7. 3, stick it in there, I get 11. 4, stick it in there, I get 15. 5, stick it in there, I get 19. And therefore my series for this summation notation would be 7 plus 11 plus 15 plus 19. And if I evaluate that, the answer to this problem would be 34 plus 11, which is 45, plus 7. The answer would be 52. That's what this summation notation adds up to. Now, I want to give you one special summation formula. It's for constant terms. Anytime you have a constant term in the summation notation, the formula looks like this. When you go from 1 to some number n of a constant term, all you got to do is take n times c, and that will be the answer to your problem. That will be evaluating it. This is a special formula for a constant term. So pause the video if you need to write that down. Actually, I'm going to do one example here on the bottom. Let's say I had, what's the sum of the number 7 from n equals 1 up to 6? Well, basically, since there's no value n, that means I'm going to write the number 7 6 times. 7 plus 7 plus 7 plus 7 plus 7 plus 7. Because there's no n value in your explicit formula, so you can't stick n in there. It just says the number 7. So the number 7, 6 times added together, is equal to n times c. n is 6 times the constant term 7. The answer is 42. And that's how you use this constant formula for a summation notation. Please watch the second video because I'm going to do some specific examples of evaluating series and show you how it works. But that's the basics of series and what summation notation looks like.